Hi, 7th grade. Okay, we are going to start lesson 4 at page 59. It looks like there's a Dear Family page. Basically, what we're going to be doing in this lesson is we are going to be showing proportional relationships, but with graphs. Now, you guys, I love graphing. The coordinate plane is just really, really fun to me, so I'm excited for this lesson a lot. Basically, what you can do is you can graph a proportional relationship, because that means that if it's proportional, that it should have the same slope, okay? We're going to learn that all in this lesson. Page 60 talks about how proportional relationships can kind of like grow if it's proportional. So here's an example. Have you ever heard or seen thunderstorm approaching and wondered how far away it was? You can figure this out. After you see a flash of lightning, count the number of seconds until you hear the next rumble of thunder. For every 5 seconds you count, that storm is 1 mile away. You can multiply the number of seconds by 1/5 to find out how many miles the storm is. That means the constant of proportionality for the relationship between time and distance is 1/5. Okay? I'm not going to have us do this part, but I just wanted to read this because that is a constant of proportionality. Okay? It grows by the same constant, 1/5. Let's go ahead and look at page 61. Previously, you learned about the constant of proportionality in proportional relationships. In this lesson, you will learn about how graphs and equations can represent proportional relationships. Fiona has a goal to ride her bike at a constant speed for 2 hours. Oh geez, that's really tough. To see if she is meeting her goal, she plans to check her distance at 1, 1.5, and 2 hours. She makes a graph to see these distances, or what these distances should be. What points should she plot for 1.5 and 2 hours? Okay, so let's go ahead and see. We've got this little graph over here. So we've got 0 hours, and obviously she's gone 0 distance. In 1 hour, she goes 8 miles. I think we're supposed to know that by this little picture up here. 8 miles per hour. Okay, so if that's the case, what should she be at 2? Well, here's the cool thing about graphing. We do this thing called rise over run, which means I want you to figure out how much you have to rise, and then I want you to figure out how much you have to run over to get from dot to dot. So for example, we rise up 2, and then we go over 2. So the rise was 2, and the run was 2. We rose up 2, we ran over 2. Okay, so if this is a constant proportion, that means that the next dot will be up 2 over 2. Okay, now that's great because now I know how many miles she'll go in 2 hours. So in 1 hour, she will go 8 miles. In 2 hours, she will go 16 miles. What about 1.5? She did want to know how far she'd be in 1.5 hours, right? Okay, well, if we have a unit rate, which we do, it's 1 hour is 8 miles. Can I now divide that in half to get a half of a mile? So like if I had a half mile right here, oh sorry, half hour, not half mile. Half hour right here. Couldn't I then tell how many miles that'd be? I mean, what's half of 8? 4. Now I know how much a half hour takes her. It takes her 4 miles. So if that's the case, to find 1.5 hours, can't I just take 4 plus 8 and get 12? Yeah. Okay, so how we figured this out was we did this thing called rise over run. We figured out how much we got to rise and then how much we got to run over to get from dot to dot. Now that only works if they give us our dots, right? Now can I figure out how far she'll go in 3 hours? Yeah, just go up 2, over 2. Okay? And I should be able to draw a perfectly straight line if, I had a nice ruler that goes right through all these points. That line was terrible. I don't know if I can do any better. I guess that's a little better. Okay? And it should just keep going and going and going. All right. What points should Fiona plot on the graph? What do the points represent? Now, we could have plotted the half on there, the 1.5, but we didn't. We just plotted the 2. We plotted the 2 for the hours. But basically, what do the points represent? They represent how far she rides her bike in how many hours, right? Number 2. You can use ratios represented as points to find other equivalent ratios. You can also represent proportional relationships in the coordinate plane. So look at this graph over here. The graph at the right shows a proportional relationship between x and y. Basically, it's a straight line if I were to draw my points through that. Why does this mean all the x to y ratios are equivalent? Well, if it's a proportional relationship between two quantities, it means that the ratios are equivalent. So if they're telling me that it is a proportional relationship, then I know the x's and the y's are equivalent as well. So let's go ahead and prove this. I'm going to go ahead and write the coordinates for all of these. So it looks like, Willa Jean, get out of here. That first dot is over 1 up 1.5. So it's 1 comma 1.5. The next one is over 2 up 1, 2, 3. The next one is over 3 up 4.5. And this last one is over 4 up 6. Okay, I can tell that there is a rise over run. Can you guys see a rise over run? Let me do the rise over run in red. From here to here, how far do I have to go? I have to go up 1.5, so my rise is 1.5, and then I have to run 1. Let's see if this is a constant proportionality. Do I go up 1.5? Yes. And then do I go over 1? Yep. Up 1.5, and then over 1. Up 1.5, and then over 1. So I know that my constant is going to be 1.5 over 1. That's what my rate is, okay? B says, how can you move from point 1 comma 3 halves, 1 comma 3 halves, to 2/3? How can you move from 1 and 3 halves to 3 and 9 halves? Okay, they're confusing us by putting 3 halves, 9 halves. Let's turn those to decimals. You guys, 3 halves is the same as 1.5. And then 9 halves. How many times can 2 go into 9? Looks like it can go in there 4 times, because 4 times 2 is 8 with 1 left over. So it's actually going to be 4.5. Okay. So 3 over 3 up 4.5. That's exactly what we got right there, right? 3 comma 4.5. Okay, how can you move from this point to this point, and then from this point to this point? Well, we figured that out, remember? We found the rise over the run. The rise over the run was 1.5 over 1. When we find rise over run, we're actually finding the slope. Slope is how steep or gradual a line is, okay? So this slope is 1.5 over 1. We could just say 1.5, obviously, right? For every x unit you move to the right, how many units do you move up? And how can you use this information to find the constant of proportionality? Okay, so for every x, how many do we have to go over for y? Basically, that's what it's saying. So for every time we move to the right, which is how many times? Every time we go up, let me see here, 3.5, which is the same as 1.5. You move 1.5 units up for every 1 unit you move to the right, which is the slope, right? This is such an easy question. It's just really complicated. Basically, it's asking us, what is the slope? The slope is 1.5 over 1. What that means is we go up 1.5 and then move over 1 to the right. If you can find the slope, then you can find the constant of proportionality. Okay? Constant of proportionality is slope. Slope is rise over run. The equation y equals 3.5x also represents the proportional relationship. How does the equation show the constant of proportionality? I'm going to give you guys a little tip here. This is not something that you guys have learned yet, but there is this equation called y equals mx plus b. Okay? And now what this is this is a normal line equation. So what we'll do is we'll memorize what each of these means. M stands for slope. B stands for the y-intercept. A y-intercept just means where on the y it crosses. So the y-intercept of this graph would be 0, 0, because it crosses the y at 0, okay? And the slope, we already figured that out, was up 1.5 over 1, up 1.5 over 1, up 1.5 over 1. That's slope, okay? So if I were to make this a graph, I would say y equals slope, which is 1.5 over 1, x plus 0. Now, if the y-intercept is 0, you don't need to put plus 0. It's unnecessary because it's kind of silly. Like, it's anything plus 0 is just the other number, right? So we're just going to get rid of it. We don't need the plus b. Okay? How does this equation show the constant of proportionality? This right here, let me highlight it. That is slope. If it's butted up next to the x and it equals y, that's the slope. It's just that we wrote the slope like this because it made more sense in our graph. Isn't 3/2 the same as 1.5? Yes. I like saying 1.5 because it's so much easier to say go up 1.5 over 1, up 1.5 over 1, instead of saying go up 3.5 over 1, 3.5 over 1. How is using a graph to represent a proportional relationship like using a table, and how is it different? So, for example, if I was showing it with a table, I wouldn't have to go find the slope, because a table would already just show us the proportional difference. But with a graph, I have to go find the slope, okay? So let's say with a table, you don't need to find the slope. The reason why you don't need to find the slope is because they already give it to you. If it's in a table like this, x's and y's, and they say like here, let's use these x's and y's right here. Let's use those points, okay? So this is an x, so I'm going to put that 1 in the x's. And then the y is 1.5. Okay, how about 2 and 3? The 2 is in the x, the 3 is the y. 1 and 1.5. Oh, up 1, 1.5, up 3. Okay, so we'd have 3 and 4.5. Okay, if I had a graph like this, or a chart, or a table, I don't have to find the slope. The slope is already there for me. Slope is rise over run, which is the same thing as my y's over my x's. What's my y over my x? 1.5 over 1. So if they give you a graph, you don't have to go find the slope. It's already there. However, with a graph, we have to find the slope. All right, we're going to do green pages together, 63 and 64. Hey, old man. And I want you to scan page 62, and I want you to put that in your assignment and turn that in. Okay, biggest thing I want you guys to get out of this lesson today, here, I'm going to write this right here. Let me get my highlighter. You guys can do this too. Right here. See this little spot? This is like the big idea, okay? The big idea from today. Let me go and get nice, like, strong color that we can realize. Here's our big idea. Constant of proportionality. Okay, that word right there. Constant of proportionality is the same thing as slope. Okay? It just means how much did it go up, go over, go up, go over, go up, go over. Constant of proportionality is slope. Slope is rise over run, which is the same thing as y over x. Okay? So if you were to take the coordinates, you'd put the y's over the x's. Okay? That's what I want you to get the big idea out of this chapter, out of this lesson. Constant of proportionality is the same thing as slope. How do you find the slope? You count how many you go up and then how many go over. How many go up and then how many go over. Now, if they don't give you a nice little graph like this and they just give you a table, you can still find the slope by taking the y's over the x's. 1.5 over 1. Okay? This is your big idea that I really want you to get, okay? Constant of proportionality is slope. Slope is rise over run. All right, guys. See you tomorrow.